Welcome to Building Knowledge 101. In this video, we review how different glazing methods impact fallout drift, including the seismic performance of structural silicone glazing versus structural tape glazing. So with unitized current wall systems, they're either designed to be glazed either using tape on the interior or silicone on in the interior to secure the glass back to the frame. Regardless of how the system is glazed, you can get the same testing results with both systems. However, you do have to test both. Since the glazing method is different between the two, you can't use one test to qualify the other. But let's say this was SSG instead of being tape glaze here. So it's the exact same system, but just at a slightly different depth. So instead of being 7.5 inches, maybe it was 10 inches. You will be able to use the same test to qualify both different system depths. So you have to test each system, but just not each system depth. But if the glazing methods are different, then you must test that glazing method. Also, your glass has a big impact on the fallout drift. So remember, anneal glass is the weakest glass, laminate being the best glass. So anneal glass is going to give you a worst case scenario. Also, glass size has a big impact as well. So smaller glass size from tested will perform as good as better. So if you have testing at a 5x10 system size, if your actual project is using 4'8" instead of 5'10", you know that you're going to get that same level of performance or better performance. Here's just a recap of some of our test results. So again, remember all our systems were tested with the weakest glass, anneal glass, and laminate glass will give you slightly better performance. So, and each different system type must be tested. So even though we have two stick-built systems, just captured versus SSG, you have to test both those systems. You're not able to qualify both systems with one test. Also note that here, delta cracking was 3 inches and the glass fallout was 4.9 inches. And then your fallout ratio is 3.2%. But if you look at those ASE 7 calculations, you would end up with 2.55 inches. So if you compare that to the actual real-world testing, you see that you get much better results with testing. And again, for the two-sided SSG system, in this case, the calculations only account for 2 inches before you have fallout. But when doing our actual testing, there was no cracking and no fallout at all, and you were able to accommodate up to 6% movement. Also note the base size. So in general, just always pay attention to the base size again. So the smaller glass is, the more movement that you can accommodate. So make sure that the glass size in the test report matches or is bigger than the glass size for your project. One thing we see is that ALMA 501.6 and 501.4 specifications done incorrectly. In this case, you can see that for ALMA 501.6, we're calling out a design displacement and also 1.5 times the design displacement, which is incorrect, as there is no design and there's no 1.5 times design displacement during the 501.6 test. You're simply just going to record what the glass cracking and glass fallout is. And then in this case of ALMA 501.7, it is not a seismic testing standard, so it shouldn't be in your seismic performance section. It should be either standalone or in a different performance section. So this is the correct way to detail the test method. So in this case, we're calling out ALMA 501.4, testing to design displacement of 1%, and then 1.5 times that, so 1.5% through the 3 cycles, which is correct. And then you're also calling out the air and water test as well. So this is good detail in the test methods in doing the ALMA 501.4 testing.
That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.